Welcome back to Low Stress Math with Mrs. Bono. We are in Book 3, Chapter 6, Lesson 6, Dilations. All right, list any differences or similarities you notice between the two triangles. Stop the video and try the work. You can do this. We've done it before. All right, welcome back. Let's take a look at some similarities. Well, similarity 1, they have the same orientation. It's the first thing I noticed. And they're the same shape. But this one's a lot bigger than the other, so the size is different. And let's see, ABC, ABC, they have the same angles. So same shape, same angles. I wonder if the sides are in proportion. Well, we'll find out soon. So size is different, orientation is the same, shape is the same, location is different. All right. Now, what do you do to triangles ABC in order to get triangle? Well, put my glasses on so I can see which one has the primes. Okay, this is the original, this is the prime. So this one is much bigger than this one. Let's see, this is 2, this is 2, 4, 6. Let's see, this is 2, 4, 6, 8, 9, 3. I think you multiplied by 3. What do you do to triangle ABC in order to, I think you multiply by 3. That's what I think. Scale factor is the number used to what? Scale factor is the number used to multiply the pre-image in order to get the image. If the scale factor is larger than 1, the image will be bigger. If the scale factor is smaller than 1, the image will be smaller. So, like up here where I said I multiply by 3, 3 is bigger than 1. That's why it went from a smaller image to a larger image. But what if I said we divided by 3 or we used 1/3? Then the larger image would go to the smaller image. All right, what's going on here? Here are some examples. This big one went down to this little one. So let's call this A and this A prime. And this was, say, I think this is about half if I measured it. Let's measure it. Here we go. This is a little over 1.5 centimeters. And this is, about 1 centimeter. So yeah, I think this is about half the size, close anyhow. So this one is half the size. So A prime, half the size of A. So it got smaller. This one got bigger. Let's measure this one too. Let's come here, you. That is about 1 centimeter, and this is about 2 centimeters. So this one's twice as big. So A prime, B prime, C prime is 2 times the size of ABC. I should put triangles in front of that. Yeah, triangle A prime, B prime, C prime is 2 times the size of ABC. So that's how I got bigger, because 2 is bigger than 1, half is less than 1. All right, a dilation is a transformation that either enlarges or shrinks, or, yeah, enlarges or shrinks the size of the original figure by a given scale factor. To dilate a figure, multiply x and y coordinates by the scale factor. Now, so far, we've had capital R for reflection, sorry, little r for reflection, capital R for rotation, and T for translation. What do you think dilation is going to be? D, dilation. And then down on the bottom is going to be the scale factor. So in other words, if I have D 1/2, it's going to get smaller because it's less than 1. And if I have D 2, it's going to get larger because 2 is bigger. So let's take a look at the next page. Here we go. All right. The arrangements of points after a transformation does not change. That's the orientation. So DC, C times X, C times Y. C is the scale factor. Multiply each coordinate by the scale factor. By the way, the reason they're using C for scale factor is C is a constant. So it's a constant number. You're constantly multiplying by the same number. All right, graph ABC using these coordinates. A is at 1, 2, B is at 1, 5, and C is at 5, 3. Okay, so A, B, C. And since I have my ruler handy, I can connect my dots and have a nice little triangle here. Now, my dilation has a scale factor of 2. That means I multiply every single number times 2. So, for A prime, it's going to be 2 times 1 and 2 times 2. 2 times 1, 2. 2 times 2, 4. A prime is going to be at 2, 4. Now, because it's 2, I don't actually have to write it all out. I could just multiply in my head. So 2 times 1 is 2. 2 times 5 is 10. So B prime is going to be at 210. 2 times 5 is 10. 2 times 3 is 6. So C prime is going to be at 10, 6. So let's just graph that. 2, 4, A prime. 2, 10, B prime. And 10, 6. Where's 6? Right there. And 10, C prime. Okay, so play connect the dots. Oh my goodness gracious me, look at that. It's overlapping. It's okay to overlap. We've talked about this before. Many, many times your image and your pre-image are going to overlap. You will graph a pre-image, and then when you graph the image, it overlaps. So, draw math after a dilation of 1/2. Well, first I have to know what the coordinates for math are. So this one is at -6, +6. So -6, +6. A is at +4, +6. T is at +4, -2. And H is at -6, -2. Now, multiplying by 1/2 is the same as dividing by 2. Let's write that on the bottom. Multiplying by 1/2 is the same as dividing by 2. So, -6, +6, divided in half is -3, +3. 4, 2 is 2, 3. For -2, be careful, is 2, -1, -6, -2, -3, -1. Now, 1/2 is less than 1, and all of these numbers are smaller than the original because we divided by 2, so we're going to have a smaller shape. M1 is going to be at -3, +3 for M prime. A is going to be at 2, 3 for A prime. T is going to be at 2, -1, T prime, and -3, -1 for H prime. And I should use my ruler, but here we go. It's all been cut in half and made a much smaller figure. Matter of fact, it's half the size. Okay, let's take a look at the last page of this. Triangle ABC has a scale factor of 3. What does the symbol for this dilation? Well, remember, it's D, and then the scale factor, which they use C for constant. I would use SF, whatever. 3. What is the algebraic rule? Okay, so I have X and I have Y, and I'm going to multiply the scale factor 3 times X, but also 3 times Y. What are the vertices after the dilation? Okay, so this is the original, and that means that I have A at 1, 1, B at 2, 3, C at 4, 1, and I'm going to multiply everybody times 3. For A prime, 3 times 1 is 3, 3 times 1 is 3, so A prime is at 3, 3. 3 times 2 is 6. 3 times 3 is 9, so B prime is at 6, 9. C prime, 3 times 4 is 12, and 3 times 1, oh, I closed my parenthesis too soon. The devastation. Oh no, where's my whiteout? Oh, there you are, darling. Come here. Here we go. 3 times 1 is 3. Okay. Now, here's some interesting things. It doesn't ask me to graph it. I can't graph it. I don't have enough space. But it did ask me for the vertices after the dilation, and that would be the red ones. Okay. What are the coordinates of this image after a dilation of 1/3? So this is at 0, 3. I didn't write it down. Here we go. A is at 0, 3. B is at -3, -3. And C is at 3, -1. Now I have to divide everybody by 3, because 1/3, it's the same as dividing by 3. So A prime is at 0. 3 divided by 3 is 1. B prime, 3 divided by 3 is 1, so -3 divided by 1, -3 divided by 3 is -1. And 3 divided by 3 for C prime is 1. -1 times 1/3 is -1/3. Sometimes you get fractions in your answer. It's okay. What's the ordered pair for A prime with a dilation of a scale factor of 5 if the original coordinate? Okay, so here I have -4, 8, and the scale factor is 5. So -4, oh, and this is A. -4 times 5 is -20. -8 times 5 is positive 40. So I'd be at -20, positive 40. Okay? Which transforms that are congruent to the pre-image? Congruent means the same size and shape. So a reflection is the same size and shape, a translation is the same size and shape, rotation is the same size and shape, but not a dilation. Which transformation produces an image similar, same shape as the pre-image? And they want dilation here. Even though all of them are similar, they just want dilation. Okay, guess what? Your homework is page 61. The independent practice. You can do this. I'll talk to you soon. Bye.